Hello everyone, myself Mrs.S.Nusrath Najeeba, Assistant Professor, Department of Computer Science SF from the Standard Fireworks Rajaratnam College for Women, Sivahasi. In this video, we are going to learn about what is a data structure and how we are using it. This is the contents of today's video. First of all, we see the introduction for a data structure, then why we need a data structure, then we see the classifications and the abstract data types of a data structure. First, see the introduction of a data structure. A data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. A data structure is not only used for organizing the data, it is also used for processing, retrieving and storing data. Different basic and advanced types of data structures are used in almost every program or software system that has been developed. Data structure are an integral part of computer used for the arrangement of data in memory. They are essential and responsible for organizing, processing, accessing and storing data efficiently. Various types of data structures have their characteristics, features, applications, advantages and disadvantages. Then the need for a data structure. The structure of the data and the synthesis of an algorithm are relative to each other. Data presentation must be easy to understand so the developer as well as the user can make an efficient implementation of the operation. Data structures provide an easy way of organizing, retrieving, managing and storing data. Here is a list of the needs for data. Data structure modification is easy. It requires very much less time. Saves storage memory space. Data representation is also easy in that. Easy access to the large database. Then the classification of a data structure. Data structure has many different uses in our daily life. There are many different data structures that are used to solve different mathematical and logical problems. By using data structure, one can organize and process a very large amount of data in a relatively short period. Data structure are normally divided into two broad categories, the primitive data structure and the non-primitive data structure. First of all, we see the primitive data structure. Primitive data structure. These are the basic structures and directly operated upon by the machine instruction. In general, there are different representation on different computers like integer, floating point, character constant, string constant, pointers, etc. fall in this category. Then we are going to see about the non-primitive data structure. These are more sophisticated data structures. These are derived from the primitive data structures. The non-primitive data structures emphasize on structuring of a group of homogeneous, that is the same type, or a heterogeneous, which refers to the different type of data. The non-primitive data structures is then further classified into linear and non-linear data structure. Linear data structure. Data structure in which data elements are arranged sequentially or linearly. That is, where each element is attached to its previous and next adjacent elements is called a linear data structure. The examples for a linear data structure are array, queue, stack, linked list, strings, etc. The linear data structure can be further classified into static data structure and dynamic data structure. Static data structure has a fixed memory size. It is easier to access the element in a static data structure. An example for this data structure is an array. Then dynamic data. In this, the size is not fixed. It can be randomly updated during the runtime, which may be considered efficient concerning the memory space complexity of the code. Examples for this data structure are queue and stack. Then non-linear data structure. Data structures where data elements are not placed sequentially or linearly are called non-linear data structure. In a non-linear data structure, we can't traverse all the elements in a single run only. Examples for nonlinear data structures are trees, graphs, tables and sets. Then the abstract data type. A data type that is defined entirely by a set of operations is referred to as abstract data type or simply ADT. Abstract data types are a way of separating the specification and representation of data types. An ADT is a black box where users can only see the syntax and semantics of its operation. An ADT is a combination of interface and implementation. The interface defines the logical properties of the ADT and especially the signatures of its operations. The implementation defines the representation of data structure and the algorithms that implements the operation. An abstract data type encapsulates data and functions into a named data type. It is similar to a structure in C, but in structures we can't include a function. In this we can include a function. The basic difference between ADTs and primitive data types is that the latter allow us to look at the representation, whereas former hide the representation from us. And ADT consists of a collection of values and operations with the values derived their meaning solely through the operations that can be performed upon them. These are the ADT collections. It is a data structure and a set of operations which can be performed on it. A class and object oriented design is an ADT. The precondition defines a state of the program which the client guarantees will be true before calling any method. The post condition. This defines the state of the program that the object's method will guarantee to create for you when it returns. Then create. It creates a new collection. Add refers to adding an item to a collection. Delete implements the deletion of an item from the collection. Find. This helps us to find an item matching some criterion in the collection. Destroy, which destroys the collection. I hope this video will be useful for you to know the basics of a data structure. Thank you for watching the video.